Namaskar, Vande Mataram. Today I am going to discuss topic of 10th standard application of trigonometry. It's a very interesting topic, but some students find it a little difficult. So here, in general, a trigonometry problem involves a right angle triangle. Let's say triangle ADE here. Triangle here. Say this is the right angle, right? The two sides and diagonal. And they are related. Say AD divided by AE cos theta, AD divided by AE sin theta, divided by AD tan theta. So if you know these three relationships, it's possible for you to tackle any given problem in trigonometry. Now, here, two of the parameters will be given to you and other two parameters can easily find out. Now, this is one sketch variety book, and on page 196, you'll see that some kite is flying and this girl is watching that. Now, she is watching at an angle of elevation. This is the angle of elevation and this is the line of sight. Now, if she wants to get the height of this particular object, then you will necessarily a point. So let us imagine that some boy or some girl is standing here, which is exactly below the kite. And then we can measure this particular distance, we measure this angle, and hence we find out at what height the kite is flying. So this would become a sort of problem of trigonometry. Let us go ahead, have one more problem. Now, this is a very famous problem. See, you have the Qutub Minar and somebody is standing at some known distance at the base, from the base, some known distance, and you will see that this A is the ground level, whereas the point A is the eye level of the person. A person is viewing this, and maybe he uses some instrument. Normally a simple clinometer will do. With the clinometer, the person finds this particular angle of elevation and then measure this distance and find out the height of this particular tower. So this sketch here, this shows the eye level of the person. He is standing here watching this at an angle theta. Okay, and let us see what is happening. So I will read out for you. Type 2 problem. Observer at some elevation, elevated point A. So this may be eye level, or he may be standing on a building, okay? So, or maybe table, stool, anything. So this is the level from which the angle is being measured. Okay. Now, angle of object is theta. Observer is at horizontal distance AD is equal to GB. These two distances are equal. And you must know this distance to find out this height. Or if you know the height, you can find this distance. Either way. So observer is at distance AD is equal to GB. Height of the object is GB. Distance of E, the object from A, the observer is A. Given the parameter AG plus out of 4, namely AD and AE, you can find out ED and or EB. Okay, so tan theta is equal to EB minus AG divided by BG, ED divided by AD, cos theta is BG by AE, sin theta is also known to us. AE square is equal to AD square plus ED square, and EB is equal to ED plus AG. You knowing two things, other two things can be worked out. Let's look at the third type of problem. Now here, instead the observer now is at higher level. We know this height at which the observer is, and we know the angle of depression here. Now once you know this angle of depression and this, then you immediately know this angle also, because you know these two are parallel lines, and therefore this angle is same as this angle, and this is going to be 90 minus that angle. So knowing this particular side and the angle, it is possible for us to find out the distances. So tan alpha is df by AD, okay, and here I have made that particular sketch. I can move this up a bit. Okay, so this is the case. Tan theta is df by AD, and we know this df, which is, and therefore it is possible for us to find out AD. Or if you know AD, it will be possible for you to find out alpha. Okay, so f square is equal to df square plus AD square. Okay. Let's move to next. Now here, this has moved ahead. I will bring it down, this text. Okay. Now here you'll see that the parameters AD is equal to FH. AD is equal to FH. Now the same sort of problem. If observer is here, it is angle of depression. If observer is here, the angle of elevation. Okay. So knowing either AH or DF, depending on where the observer is, it's possible for you to work out this problem. So observer is on the same. The parameters are AD is equal to FH, AH is equal to DF is equal to AG plus AG, DF is equal to DV plus, and so on. So this is how it's possible for you to split this in two parts. So this is some building you can imagine, and person is at some height here. Maybe he has some tripod or whatever it is, or on the building there is some small tower and the observer is here. So this is how it's possible for you to work out the problem. Next we'll see. Right. Here what we are doing is we are trying to get two angles and this distance. So with this distance and this angle we will get this height, and with this distance and this angle we will get this height, and consequently we can find out the height. So the problem would be that you have some building or something and some object is there at the top, or maybe this is 4th floor level and the 6th floor level. So with that it's possible for you to obtain this distance kg, knowing IL, and you have what angle alpha and angle beta. So this is how you have different types of problem, but basically there are 4 parameters in which 2 are known and 2 others are to be found out. Now let's look at this particular problem. We have already seen different types of problem. This I have chosen example 3, page 199 from CBSE 10th mathematics book. An observer 1.5 meter tall is at 28.5 meter away from a chimney The angle of elevation of the top of the chimney from her eyes is 45 degrees. Find the height of the chimney. So let's go step by step. Now we are given this data. Let us draw the diagram. So here what I have done, this is the ground level and this is the eye level. Now I locate the base of the chimney. So chimney is here. And we have 28.5 the distance of the chimney, and you see that at beta 45 degree we draw one line, and wherever this line cuts, this is going to be the top of the chimney. So we have observer here with eye level at 1.5 meter, chimney is located at 28.5 meters, and the height of the top point is located by angle 45 degrees. So C is the top point. Okay. Now height of this particular chimney from this diagram itself has worked out to be 30 meters. This is the graphic solution. Now let us see the analytical solution. So in triangle SAC, I have not marked the point A. Let me show it to you. So this is the point A. So SAC is a right triangle. The base is 28.5 and angle is 45 degree. So AC is AS tan beta, which is 45 degrees, and tan beta or 45 degrees is 1, and therefore that also works out to be 28.5. To that we add the line of sight height is 1.5 meter, so total is 30 meters. So please see that you can either work out by graphics itself in this GeoGebra or use trigonometry and get the desired solution. I would suggest that you start using this software GeoGebra and start solving the problems through this. Let us study one more problem of the trigonometry application of 10th standard. I have chosen this problem or made this problem for Statue of Unity. You are aware that recently India has established statue of Sardar Vallabhbhai Patel at Ekata Nagar, which is now the tallest statue of the world. And you know that Sardar Patel was the person who united about 400 states to make our Bharat. The statue of Sardar Patel is 182 meter tall with 58 meter base. I am in the boat at 300 meters from statue. My eye level is 160 centimeter. At what distance A, D1 from my feet do I direct my binoculars in water to see the top of the statue? At what angle theta do I elevate my binocular to see the top of the statue? Here there are two parts of the question. In one part, we are looking at the statue as a reflection in the water. And other part, we are viewing directly this statue. Let us see how we tackle this problem. So I make this particular sketch. You see, this is a huge scale problem. So that is why it is difficult for you to see different points, but these different points I will make visible by expanding this at the end of this particular session. Now let us see that I make a sketch. The ray coming from reflection of the top of the statue enters my eye. It forms the image. See, this particular reflection or from this, it will be same. Okay, so we will have that particular thing. So triangles AOT dash, T dash is here, AOT dash, and triangle ABE. Now we are not seeing those ABE, they are all in a small triangle here. Okay, I will expand that and show you. The sides are along vertical and horizontal at water level. T is the top of the statue, O is the bottom of the statue, E is the eye level, EE dash is the horizontal line through eye. T dash is the reflection of top point. B, I am standing at B, right here. Angle of elevation is E dash ET. T dash E line the reflection of the water. Now let us see these things here. See, this is what you have. This is when you look down in the water. I am not showing this ray, I am showing its reflection here. So this is one way of looking at the statue, that is looking in the water and seeing the top of the statue, or directly look at the top. See, so this is what is happening. Now it is difficult for you to get this particular detail when you draw the full sketch in this small screen. So this small triangle, that is this particular triangle, this particular small triangle and triangle form here, they are going to be similar triangles. So by solving those similar triangles, you will get the solution. That is not the trigonometry problem. Whereas the trigonometry problem is here. This right angle triangle, we know this distance, we know this angle, and therefore we can find out this particular height. To that we add this and then get the total height. Okay, so this is what is happening. So I will put that also. So step T2. So this is the solution, right? And this is for your similar triangle, and this is for this thing. If you have this particular angle and this distance is known to you, so you can get the height. Or by solving these two similar triangles, you get this particular side you can get and relate that to the height of the statue. Okay. So yes, so this is what you are going to get. I would suggest that you try this in GeoGebra as I have done, okay, and appreciate yourself how things work. Right. So I have shown you expanded thing. So this is a thing. I mean, we should be proud of this particular statue. So every book has the Minar. So I thought, why not we take this now for our trigonometry problem or similarity problem. Let us tackle one more problem of application of trigonometry. Now here, this problem is from 10th Math CBSE on page 205. Okay, so a car and tower, call it. Okay, a straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degrees. Car is approaching the foot of the tower with a uniform speed, and 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower. Let us understand the problem. That car is moving in a straight line towards the tower. Somebody is sitting at the tower and watching that car, and simultaneously we are observing the angle made by the line of sight with the car. Angle of depression, that is from the horizontal line from the point of observation. Initially, the depression angle is 30 degrees. As car comes nearer and nearer, the angle of depression will keep on increasing and finally it will become 90 degrees. Okay, so let us see how we tackle this problem. We'll make solution step 1. Now let's see, we take some C1 is the position. The man standing at the top of the tower observes the car at depression 30 degrees. So person in the car must observe the man on the tower at the elevation angle of 30 degrees. For person on tower it is angle of depression. For the person in the car it is angle of elevation. So let us draw that. At the end of 6 seconds, the car will be at 6 meters from previous position at C2. Okay. Now let me draw that thing, and then we'll take it step by step. So car right now at t is equal to 0 is here at 0. Okay. And angle of elevation is 30 degrees. So we get angle of depression also to be 30 degrees. So I am reversing the problem. The person is looking at the tower and is having the angle of elevation as 30 degrees. Okay. Now when you move this from C1 to C2, the angle of elevation is going to be 60 degrees. So we have located this point C2 when angle of elevation is 60 degrees, or we can say that we have got this by angle of depression of 60 degrees. Okay, right. So draw at line the elevation 60 degrees from C2. It cuts previous line at top of the tower. If you draw a line 60 degrees, it will cut there. I have not drawn that as yet. Right. Now it takes more seconds to reach the base. Now it is at 3 meters from the base, so that it takes 3 more seconds to reach the base. Okay. So I will show this thing. So it is here. Right now I'll adjust it here. So this is the second position. Okay, this was the first position, This is the second position. Okay. So you'll note that it took 6 seconds to travel this distance, which I have taken purposely 6, and this as 3. Okay. So now you'll see that as it takes 6 here and 3 here, the total time taken will be 9 seconds. Okay. So this will be 6 seconds and this will be 9 seconds. I can show this animation to you. Right. So this is how you can make the problem interesting with the help of GeoGebra. So this can be made very, very interesting.